Hey guys, good evening. It is John C. Morley here, serial entrepreneur. Welcome to IFYL. By the way, if you're celebrating Easter with me, happy Easter to you. A very blessed, happy, and a wonderful Easter today. It is March 31st, 2024. You know what that means? Tomorrow is April 1st. So be on the lookout because a lot of your friends and colleagues are going to try to trick you up with some April Fool's Day jokes. I'll give you a little bit of scoop on what to look out for a little later so you're not sidetracked. But welcome. Thank you so much for being here. It is Sunday, March 31st. Great to be with you. Whether you're here with us at 8:41 p.m., 8:41 in the morning, 3 a.m., 3 p.m., 1 a.m., 1 p.m., it doesn't really matter. Thank you so much for being here. Really do appreciate that. You can check out my hat. My hat says believemeachieve.com. I know you got to take a look at that. Believe me achieve.com. All right, let's get right into the show, shall we? I thought you'd never ask. So our master topic for the week, I know you guys know what that is. It's what is M equals E times V? What is M equals E times V? What is M equals E times V? Okay. So when we think about that, we're talking about the motivation equation. Okay. And so motivation is a very big equation. And so we start out with the expectancy times the value it places to us. And that gives us basically what the motivation, the outcome will be. And we're talking about lots of other different types of formulas this week because I think that's really cool. So the master topic for tonight's show, the granular topic, is this, ladies and gentlemen. Here it is. Elevate your equation, unleashing success with John C. Morley, Series 3, which means we're in the third year, Show 14, Episode number 2. So let's dive right in, shall we? All right. So what is a formula? A formula, unraveling the secrets behind the formulas that drive our world and learning how to create your own recipe for success. That's what we're going to be talking about a lot this week. So when we start to understand a formula like M equals E times V, just like I explained to you guys before, M equals E times V, you'd be like, well, John, what the heck is M equals E times V? And I'm going to explain this to you once again. It's pretty simple. So it's the motivation equation, okay? So E is the expectancy and V is the value that we put on something. And that will give us the inherent result of M. Okay. So expectancy, okay, times the value, okay, will give us the actual motivation. But there is another caveat to that. We call it a denominator. We have to divide that by the impulsivity times by the delay. So we take the expectancy, okay, times the value divided by the impulsivity. So basically you could take the expectancy times the value to get our numerator. And then we divide that by the impulsivity times the delay, and we get our motivation factor. Pretty cool, right? All right. So I want to talk to you guys about a new formula that I've come up with. The formula is, and don't panic, it's R equals C plus L plus P plus O plus E plus I. Let me say that again. R equals C plus L plus P plus O plus E plus I. I promise I'll simplify this for you. Let's delve a little deeper into the core elements that fuel innovation and transformation from the context to evaluation. I'm going to decode the essential components that drive our progress. Are you ready? Here we are, guys. So innovation, which is what we're going after, right, is a context. So people ask me, John, what is a context? So a context is the circumstance, the form, the setting for an event, the statement, the idea, what it's surrounded by, the parts of something that it's contained within. For example, you might hear people say, we know you've taken that out of context. And what they mean is that you haven't really understood what they've said. You took a part of something they said, but you took it out of context because you didn't really mean it. I said, well, you're not following this, or you're not getting it. And or it might be something like, really? And that you take that out of context thinking that they're all mad at you, when what they're really trying to say is pay attention, because you've almost got it. So when you take something out of context, it can be a big problem. So innovation equals context. We all know what leadership is by now. We've talked about leadership a million times. Plus planning. That's right. I said plus planning. So plus planning, plus we have another area here, ladies and gentlemen, and that next level is operations, plus the evaluation. So plus the evaluation. So I think that's very important. Okay. So we have to remember how these work. Okay, because we have to put them all together. That's probably the most important thing. So let's go back and think about this again. So we've got our basic formula, which is the result. Our result is R. Okay. In our case, our result is actually going to be our innovation. That's what we are solving for, our result. Result will be C plus L plus P plus O plus E plus I. That's our result. Our result equals C plus L plus P plus O plus E plus I. What's our result? Our innovation. So innovation can be thought of as basically something else that equals it. That's how a lot of things work in our world. So in order to get innovation, we take our context, what something's surrounded by, the leadership for with we have or that other people are putting forward, the planning, what went into that, the operations, what's going on to produce that, the evaluation. Are we on track with what we think we're saying or what we believe we're doing? The best way I want to explain evaluation to you guys is going to be called the scientific. Maybe you guys know of it. It's one of my favorites, being John the Science Guy a lot. It's called the scientific method. And I'll probably do a whole show just on that sometime. But scientific method starts out by an observation. We ask a question. For example, if I go ahead and I add, let's say, a hot ice cube, I add a cold ice cube, excuse me, to boiling water, what's going to happen? Well, that ice cube is going to pretty much melt away immediately. But let's think about that a second. So what will happen? Let me ask this again to you. What will happen if I add an ice cold cube to a boiling, let's say a boiling cup? What's going to happen? So because the hot water vapor gets cooled down by the cold ice cube at the top, therefore it loses its energy. So it changes the phase back into liquid water. So the process is called condensation. Now, you want to be careful with this, because if you've used hot water, for example, if you had something cold, you put the hot in, and it could be a lot stronger, that could be a problem. So if you have like a pot or something, you put it, you wouldn't want to take, for example, a very cold glass and then put hot in, because it would shatter the glass in most cases. So my scientific question is, what will happen when I drop a cube, an ice cold ice cube, into a let's say a boiling pot, metal pot? Okay, so I'm going to ask the question. I'm going to research the topic. I'm going to form my hypothesis. My hypothesis is that I believe that the ice cube will immediately disappear. It will condense into a different form, which is actually the liquid, right? So it will go from basically, the one phase back into liquid water, and we're going to see it's going to go. And will it make a noise? So that's a question. Will it make a noise? So I think that's going to be interesting, because The sudden change in temperature pressure can cause the glass to crack or even shatter due to thermal shocks. You got to be careful where you do this. What happens when you put ice in a cup of boiling water? The ice will melt faster in boiling water, less faster than if it was in room temperature, and slower if it was in cold water. All right, so now we understand what the hypothesis is. Then we go ahead and we actually do the experiment. We test it. Then we analyze the data. What happened? We report the conclusion, we write it down, and we finish. So in our case, our innovation is context. We have leadership, we have planning, we have operations, but we have to evaluate, how are we going through all those stages? What are we actually doing? And then how can we make the process better next time? So let me go back to this formula, which I think is amazing, which is R, and I just came up with this. So it's results. Our results, the result we want to achieve is our C plus L plus P plus O plus E plus I. So result, remember, is our innovation. That's what we're solving for. Context plus leadership plus planning plus operation plus evaluation plus improvement equals our result of innovation. So let me say it again. Context plus leadership plus planning plus operation plus evaluation, okay, plus improvement. So our result of innovation is context plus leadership plus our planning plus our operations plus our evaluation plus our improvement will give us innovation. That's pretty cool, isn't it? So a lot of people think that to be innovative, you just have to be creative, but it's more than just being creative. You can have an amazingly great idea, but you won't get innovation. You might get something that's cool, but first of all, it might not work. Second of all, beside it not working, the process might not be there to get it to work. So it might be a people issue, could be a resource thing, could be the experiment is flawed. Now, every hypothesis has to have basically a result. Every one of them, they have to have a result. So we observe, we research, we hypothesize, we ask the question, we test it, then we observe the results, we analyze the data, we report the conclusion, and then we can make more observations or more questions. And this is known as the scientific method. So this whole week, we're going to be talking about different formulas, not just the M equals E times V. We also talked about E equals MC squared. You remember we talked about that yesterday? You know what that is? E equals MC squared. So E equals MC squared is a very, very simple equation by the German-born physicist Albert Einstein. We all know him, right? So what does E equals MC squared mean? In simplicity, energy equals the mass, remember equals, times the speed of light squared. So energy equals the mass of something times the speed of light squared. That's it. So you take the mass and then you multiply it times the speed of light squared and you get energy. That is so cool, right? So Einstein's big rocket moment is the famous equation of E equals MC squared. So energy equals mass times the speed of light squared. Okay? And the equation states that energy and matter are interchangeable. Okay? And there are different forms of the same thing. So where can we see E equals MC squared every day in our life? So energy equals mass times the speed of light squared can be seen every day with the sun and every star in the universe. Nuclear fusion, hydrogen and helium atoms fusing together, while much of their mass is converted to energy. So I'm going to say this again. We can see this with our universe every day with using nuclear fusion, in which hydrogen and helium atoms fuse together, which allows us to see the mass, which is converted to energy. So the full equation is pretty cool. But did you know the equation is incomplete? The full version of Einstein's equation is actual E equals M2C4 plus P2C2E equals the square root of the bracket M raised to the 2, C raised to the 4 plus P raised to the 2, C raised to the 2, close bracket. So E equals M2C4 plus P2C2, which states that the relativity of energy, E of a moving object, is a function of the mass and its momentum, as well as the speed of light. So energy is E equals mass, okay, times the speed of light squared, but it's also in proportion to the relativity of energy. Okay, it's momentum. So I think that is important to understand. Did they disprove EMC squared? No. It's taken more than a century, but Einstein celebrated the formula equals MC squared has finally been corroborated. And this is due to a heroic computational effort by the French-German Hungarian physicist. So, for example, burning a gallon of gasoline, 3.78 liters roughly, releases about 132 million joules of energy, which is enough energy to make 14 nanograms of mass, which is roughly the mass of a singular particle of very finely ground flour. So why, you might be asking, is c the speed of light? So the speed of light is now represented by a universal symbol c, and the symbol originated from the initial letter of the Latin word celerity, meaning swift or quick, and the symbol was used by Weber and Kohlrausch in their papers in 1856. So I want to just wrap up one more thing before we finish tonight, and that is the fact that formulas, when we get how to do something, we put it into a formula. I'm not going to give you my whole secret here, but one of the things I do lots of times, memorizing so many passwords, is I have a formula that I use. And I apply that formula depending on what it is. And I have different things that I plug into them based on whether it's this company, that company, and certain values. And that gives me my password. So I don't have to remember 5,000 passwords. I just have to remember maybe half a dozen formulas. Pretty easy, right? Pretty cool. So just like E equals MC squared, and just like R equals C plus L plus P plus O plus E plus I, and let me go into that again. R is our result, which is innovation. Our innovation is equal to our context that it's in, the leaders plus the leadership, plus the planning, plus the operations, plus the evaluation, plus the improvement, gives us the result, which is innovation. Ladies and gentlemen, you know who I am by now. I'm John C. Morley, serial entrepreneur. It's been an amazing privilege, pleasure, and honor to be with you this fantastic evening. Please do check out believemeachieve.com for more of my amazing, inspiring creations. Like, love, support the content. Be sure to subscribe to me on TikTok. We can't wait to stream live on TikTok. We'll be streaming lots of other places. And we've got lots more to talk about this week because we're going to be diving into some different formulas. If you remember, the beginning of the week, we talked about M equals E times V. Tonight, we talked about this formula. I'm going to come up with other formulas that I'll be making up for you to help you understand success. And you might say, John, I don't get it. Well, if you may not get the concept, but if you get the formula and then you're like, oh, I get this word, I get this word. When I put this, what happens when you put peanut butter and jelly together when you get a peanut butter and jelly sandwich? So I'm giving you formulas that I know work, which will give us a result. Pretty cool, right? All right, guys, have yourself an amazing rest of your evening, and I'll catch you guys real soon. And I hope you guys had an amazing Easter. But before I do sign off, I promised you that I would do one thing. What are some of the most common, let's say, April Fool's pranks friends play? So I think we'll just spend a minute or two and go through these just so that you're I guess, a little bit, on the down low here, ready for this. So one is, you know, you can think about somebody saying something like, your shoelaces are untied. So you check, and then your shoelaces aren't untied, but you look, and then they basically laugh, right? They're like, oh, April Fools. You might have heard the one, oh, was your refrigerator running? Yeah, well, you better go catch it. Well, it's April Fools. Or, there's lots of different ones out there. So let me try to give you some others that I think are kind of cool. You can do one. It's called this one's really cool. If you have people that are heavy sleepers, you can carry them into their sibling's bed and let them wake up in a different room to start April Fools on the right foot. Put cereal and milk in a bowl and let it freeze overnight. When your hungry kids try digging in, they'll get quite the surprise. So I think that's pretty cool. That's all you pretty much need to do. I mean, it's a pretty cool thing. The next thing you're going to do, and we're probably going to record a couple of these so you guys can see them on my TikTok channel. There's the juice joke. Okay, the juice joke is this: care for a drink. When someone asks to try to take a sip of the juice, they'll find out it's really Jell-O. You can take out all the contents of their underwear drawer and swap it out for bathing suits, and they'll get a little bit annoyed with that. You can fill your kid's drawer with balloons, and they wake up for school and look for an outfit. They'll be in for a colorful surprise. Toilet paper message, April Fools. Bugs in your ice. You can add a few drops of food color into the carton of milk. When your child goes to pour it into her glass or bowl of cereal, she'll get a colorful surprise, bright pink or blue or green. There's also the bathroom time hoax. So you can use a Q-tip, apply gel food coloring around the inside of the faucet in the bathroom or sink. When the faucet's turned on, you're left with colored water, and this is usually guaranteed to freak some people out. There's the pillow prank. When they thought April Fool's Day was over, here's one last prank. You remove the pillows and fill their pillowcases with several partially inflated balloons. When they put their head down to sleep, they realize you got the last April Fool's laugh. Obviously, some people like this, some people won't. There's also the cupcakes for dinner. Your family will think it's really cool that you're giving cupcakes for dinner for a moment. Bake up mini meatloaves in muffin cups. Don't forget the colorful wrappers. And then frost them with creamy mashed potatoes. Let's see how long it takes for your kids to realize that they really aren't that cool after all. So you have the whoopee cushion, salty hot chocolate, alarm clock fast forward. That might not be so funny. You can borrow a summer camp classic and short sheet your kid's bed before bedtime. And when they try to get in, they'll have the last laugh. That's a pretty cool one, right? The summer camp classic and short sheet your kid's bed before bedtime. The fake cake pop, tricky TV remote. Maybe you've had to mediate a family fight over who gets to choose the channel. Well, this prank will leave everyone really speechless and a little annoyed and confused. Put a piece of black electrical tape over the remote sensor on your television and watch your family try to change the channel with no luck. Remember, if you took the batteries out, they would just know because the light wouldn't come on. There are other things you can do too. Pop Goes the Bubble Wrap is a favorite of mine. Pop Goes the Bubble Wrap is really cool. The gag starts off on April Fool's Day with a bang. You put a layer of bubble wrap under the areas that your family frequently walks on, such as the bath mat, kitchen rug, or living room carpet, and they'll jump when the ground starts popping underneath their feet. Of course, these are just a few laughs. But remember, ladies and gentlemen, if you're going to do this, be sure to have fun. But remember, don't do anything that is going to get anyone hurt. It's always okay to have some fun or things like that. But if you feel somebody is like, not going to take this as a joke, then don't do this. Like, don't do this to a total stranger. If you know they're people you prank or stuff like that, and they're probably going to prank you back, that's fine. But don't do anything that's going to harm them, that's going to hurt them, or that's going to damage anything that they have, whether it's work or whether it's their own personal possessions. Make sure that whatever you're doing is strictly a joke and it's not going to cause damage to them. It can have a little laugh, which is fine, but don't do anything that's going to hurt them physically or even mentally. These are just meant to be what we call laughing with you, not laughing at you. And there's a difference. So on April Fool's Day, if you make the promise to laugh with somebody, it can be fun. When you laugh at the person, that's not really cool. So let's do this all in a good spirit of fun. I hope you have a good, happy April Fool's Day. And I hope that you're able to stay under the radar and not get pranked too early in the day. Have yourself a great rest of your night, everyone. And I'm going to catch you guys real soon, okay? Take care and have a great night.